This section is pretty short and will contain only one video, and it's about the graphs of exponential functions. Now we've seen actually what the graph of y equals b to the x looks like, actually ab to the x, depending on the sign of a and whether b is above or below 1. So we've seen this, and you should have it in your notes. There are 4 cases essentially. This is a positive and b above 1. This is a positive but b below 1. And then when n is negative, you have to flip around those graphs about the x-axis. Okay, so here what I want to look at is a geometric transformation of those graphs, and everything relies on what we've seen for functions. So if you've got a new function which is a transformation of an old one, so it could be, this is the general way in which you can transform a function. You can even throw in another variable here. But you have to remember that all those parameters are responsible for changing function f. Okay, so once we understand this, it's very easy to adapt it to any sort of function. Okay, so we can add basically exponential functions of the form ab to the x to our toolkit functions and just modify those. So this is exactly what we're going to do here. We're going to graph f of x equals 2 to the x plus 1 minus 3. And you have to understand how that's going to be a modification of y equals 2 to the x. Okay, so first of all, maybe let's graph. So actually, you know what? I'm going to put g here. I'm going to call this the original function f. So this is f of x, which is 2 to the x. Now 2 to the x looks like this because 2 is above 1, so it's increasing. It goes through 0, 1. Okay, now let's try to think. Okay, the first thing that acts on x is this plus 1, you see. So we're going to look at this first part, like 2 to the x plus 1. So y equals 2 to the x plus 1. How is that related to the graph of f? So you have to try to ask yourself, well, is this f of something? Is this f of x plus something? So it's definitely not f of x plus 1. f of x plus 1 would be 2 to the x plus 1. So that's not what we have here. Here we have that x was replaced by x plus 1. So that should give away the fact that it's a composition of our original function with x plus 1. So in other words, this is f of x plus 1. And when we write it like that, it's easy to understand that this is going to be a shift of 1 to the left, because of plus 1. So our 0.01, for example, is going to go to minus 1, 1. And you can try doing that. Replace x by minus 1. You get 2 to the minus 1 plus 1. 2 to the 0. You indeed get 1 for the output. So it's just shifting that previous curve 1 to the left. And then after that, all we do is we subtract 3 to the previous y values. So what is that doing? That's sending everything down. So this is a vertical shift 3 units down. Okay? So it's the same principles that we've applied for parabolas and other types of curves that we actually find here. So you see minus 1, 1 will now be sent, subtract 3 from 1, you get minus 2, so it's going to go up over here, minus 1, minus 2. And the other thing that you want to shift is this horizontal asymptote, which was y equals 0, but now you shift that 3 down, so it's going to be y equals 3. Minus 3, sorry. So our curve now is going to approach y equals minus 3 as we go towards minus infinity, and it's going to go up. Okay, what's going to be the y-intercept, x-intercept? So that's might be, well, we can try to figure out the y-intercept easily, replacing x by 0. So y is going to be 2 to the 1 minus 3, so that's minus 1. So it's going to cross here. Okay. So this is y-intercept. Okay, so it's 0 minus 1. If I want to figure out the x-intercept, well, I'm going to show you that we're not ready yet to figure out exactly what it is, but we're going to have a good idea. Notice there's just going to be one intercept. We can see it right from the graph, like it's obvious it's going to be here. What's the x-intercept? You equate y to 0 and you solve for x. Okay, so we get this. Okay, we can send the 3. The idea is to solve for x. So we need to isolate x in there. And here's a little trick. 2 to the x plus 1, that's 2 to the x times 2 to the 1, right? So here I'm using a to the m plus n. That's a to the m times a to the n. So 2 to the 1 is 2. So then I can send the 2 on the other side. So I get 2 to the x is 3/2. Okay? And now if you think about the powers of 2, right, if you get x and 2 to the x, what are the powers of 2? There's 2 to the 0 is 1. 2 to the 1 is 2. So 3/2 is somewhere in between, right? So that means the x value is somewhere between 0 and 1. Okay? So we know that this intercept, let's say it's a0, a is going to be between 0 and 1. Okay, that's pretty much all we know right now. So we're gonna find eventually, pretty soon, what the value of x is. Those of you who've taken this the course with me in the fall, you'll remember that to solve this, you use logarithms. So x is going to be log in base 2 of 3/2. Okay, which you can evaluate by taking log in base 10 of 3/2. Over log in base 10 of 2. This is a change of base formula. For those of you who are not with me and don't remember this, we're going to see that again in the following section that covers logarithms. And that will give you what x is. So using my calculator, if I calculate this, I get approximately 0.58 something. Okay, so you can see it's actually like as expected between 0 and 1. So going back here, I can actually write down this value. But right now, for many of you, we don't know how to get that value immediately. Oh, this I didn't write, but this is 0 minus 1, our y-intercept. So second example, and eventually I'll get you to participate. We want to graph f of x equals 4 1/2 to the x. Okay, so this one's actually not so complicated. It's actually of the form ab to the x. So it's one of it's a very simple case. But maybe I want to show you through the eyes of transformation of functions what the 4 does to it. Now, if you'll recall that if we start with y, which is 1/2 of x, so because b is less than 1, this is a function that decreases like that. Okay, and this is the y-intercept. Now what does the 4 do to it? Well, it's gonna, if this is imagine this is let's call it actually this h of x. So imagine this is f of x again. H is actually 4 times f of x. So if you multiply a function by 4, what it does is that it multiplies all the y values by 4. So it's a vertical stretch by 4. Okay, so vertical stretch of 4. So that means that everything is going to be 4 times higher. So my y-intercept, which was 0, 1, now becomes 0, 4. And then it decreases like this. Well, we kind of knew that because we know that when it's of the form ab to the x, I already mentioned that a is going to be our y-intercept. Okay, so that's not really a surprise, but I want to show you the 4 through the eyes of transformation of functions. So it's going to perform a vertical stretch. Now this is where you're going to participate. So say I start again with f of x, f of x equals, I'm going to start with f of x equals 1/4 of x. Okay, I said again, but we didn't encounter that function before, so never mind what I said. So f of x is this. Here's what you want to do. So find a function that reflects f about the x-axis. So here it's kind of the other way around. You're going to create a function by performing a geometric transformation. So pause the video, try to do it, and come back. Now, if we're given f of x, how do we reflect about the x-axis? Essentially, about the x-axis, we want to, if we've got a point AB on our curve, we want it to become a minus b. So I have basically to change the sign of the y value. So my function f of x, I need to multiply it by a negative sign. So let's say my new function, I'm gonna call it g of x, is going to be minus f of x. So it's going to be minus 1/4 of x. Okay, simple as that. So maybe let's frame that. G of x is minus. Careful, the minus goes in front of the bracket. And remember that exponents have priority over negative multiplication. So when you evaluate this, you need to evaluate this first, and then you multiply by a negative. Okay, so in other words, if you want to evaluate, let's say, g of minus 2, I don't know, it would be, you would do 1/4 to the power minus 2. You do that on your calculator, and then multiply everything by minus 1 in the end. Okay, so that would give you actually minus 4 to the 2, minus 16. So b, now find a function, I wrote function twice, that reflects f about the y-axis this time, and that shifts it 3 units to the right afterwards. Okay, so let's see. I'll do it in many steps. So initially our initial function, let's call it y1 is 1/4 of x. Okay, so that's our f. Then what do we want to do? We want to reflect about the y-axis. So by reflecting about the y-axis, if you've got a point AB, you reflect about the y-axis, it has to become minus AB. So in other words, now minus A will have the same y value as that A had before. Or if you prefer, minus x will have the same y value that x had before. So you want to replace x by minus x. So we saw that. So essentially, to reflect like this, you need to replace in function f x by minus x. So that does the trick. So this is going to be 1/4 of minus x, like this. So this is reflect, okay? Okay, about the y-axis. And then after that, we need to shift 3 units to the right. So how do we shift to the right? If we've got a function f, to shift 3 units to the right, we need to replace x by x minus 3. So we go back to our function, okay, there. And then we're going to replace x by x minus 3 like that. Okay. So that becomes 1/4 of minus x plus 3. I don't need to expand, but I prefer to do it. Because if I expand, I'll write it nicely as 3 minus x. So the function I'm looking for, let's call it h of x, is 1/4 of 3 minus x. And you know what? Here's another thing you can do. You can write 1/4 as 4 to the minus 1, and then multiply your exponents together. So you get minus 3 plus x, so you get 4 to the x minus 3. It actually looks even better this way. So you can write it like that as well. Okay, so either way, it's good. Okay, and you could also have left it like that, like that would have been okay too. And here's a quick question. Okay, question. Can those operations, the reflection and the shift, can those be interchanged without affecting the formula graph, okay, of the resulting function? So try, here's something for you. Try to perform the shift before the reflection and see if you get the same formula. So pause and come back. So here, if we start with this, if I shift first, okay, that means I replace x by x minus 3. This is shifting. So shift, okay, 3 to the left. And then, if I reflect, I need to replace x by minus x, okay, like that. So that gives me one, so maybe I should put 1/4 in brackets like this, 1/4 to the minus x minus 3. And here's maybe a cute way to write it down. 1/4 is 4 to the minus 1, minus x minus 3, that's minus x plus 3. And then we can multiply the exponents together. We get 4 to the x plus 3. So that would be, let's call it a m, I don't know, m of x is 4 to the x plus 3. Okay, so you can actually compare the two here, and they're clearly not the same. So the answer is that the order of the operations matters. So no, they cannot be interchanged. The order of the operations matter. So that's why I always tell you that it's important to write the operations in the right order when you describe a function from its formula, because the order actually matters.